Welcome everyone to the Fireside Chat today, which is going to discuss a very interesting topic about carbon footprint, and especially what is the footprint of AI, artificial intelligence, in particular ChatGPT. And to discuss this interesting topic, I have an equally interesting personality today with me in this Fireside Chat. A very warm welcome to Kasper Groes Albin Ludvigsen. Kasper is a well-known community leader in the space of sustainable data science. He has worn many hats during his career. He's worked with large companies. He's worked with a lot of startups, incubated it, and then found his calling focusing around data science, and especially on sustainable data science, on how you can make sure that the machine learning and the entire algorithms behind it can be made in a sustainable nature. So very warm welcome to you, Kasper. Welcome to this Fireside Chat.
Thanks very much, Archana.
Yeah. So my first reaction when somebody says artificial intelligence, machine learning, and some of the statistics that I was looking at was that few years back, there was absolutely no penetration of this topic in day-to-day psyche. And today, suddenly everybody is excited. It doesn't matter whether you are a techie or not. You are very, very excited about this topic, and everyone wants to know about it. And researchers predict that AI is going to hit revenue of nearly $1,600 billion by 2030, right? Which is a huge number to look at. Now, given this entire, I would say, clout that AI has, what is your stand on why should you even look at AI and its footprint? Is it a worrying trend for us as techies, or do you think this is just a hype and we don't need to worry too much about AI footprint?
I think currently we're in a situation where the carbon footprint is, well, it's all a matter of perspective. But if we look at the data center industry as a whole, it's been estimated that the data center industry accounts for between 1% and 5% of global electricity consumption. And from having read some of the literature on this topic, I think it's closer to the 1% than the 5%. And then whether you think this is a lot or not is a value judgment. And I typically try to stay away from making such judgments. But I think we can all agree that as AI products or AI systems such as ChatGPT becomes more widely used, which I think we all agree that it will be more widely used, then the electricity consumption from products like this will increase, and will probably increase by quite a lot compared to where we are today. So whether or not it's a lot is not something I think is really meaningful to discuss at this point, because you have to consider the trade-offs, or you have to, it's a very complex assessment to make. You can say you can estimate the carbon footprint of something like ChatGPT, but then in order to assess whether it's worth its carbon footprint, like how do you do that? Do you look at the productivity gains we accrue from this technology? That could be one way, but even if you do know the productivity gains from ChatGPT, how do you make an assessment of whether or not the carbon footprint is worth the productivity gain? So, and I also want to say that, as I just said, I'm not here to make any value judgments. I make a living from working with data science and AI. So I have no interest in stopping this development. I have no interest in stopping the adoption of AI products. But I think it's very important that we have a discussion about the electricity consumption, the carbon footprint, but also other environmental impacts that this whole industry has. Other impacts could be water consumption, air pollution, soil contamination, and this is something that we, as both as software developers and data scientists, but also just as users of technology, we should be aware that there's some electricity consumption and some carbon footprint associated with our activities, and then maybe down the line we begin, like maybe we will approach a point where we can make an assessment of whether or not we gain enough value from this technology for it to be worth it. But I think right now the numbers are very interesting, but I don't think they're big enough to really be alarming, but it's definitely something we should be aware of, and we should follow this trend closely. Yeah.
Thanks for bringing that aspect out, Kasper, because as you rightly said, there are benefits of using this technology, and we all are reaping those benefits. So instead of making a judgment whether this technology should be, if I may use the word, should not be used further or continue to be used further, the bigger point that we all as techies and software engineers need to understand and be aware that there is an after effect of it. Mm-hmm. Now, is that after effect alarming enough? Is that after effect not alarming enough? Time will tell based on how this technology evolved. Time will tell based on how we use it.
Yeah.
But my question to you would be is that today there are a lot of new graduates who are coming into the industry, mm-hmm. and who seem to want to do something with AI. Mm-hmm. There are a lot of companies who are coming up with different products, and each of these products will say that, hey, you know what, my product is AI enabled, it can take some decision, it can look at some predictions. So everybody is jumping on this bandwagon. Mm-hmm. Now, when this is the situation that you see happening in the industry, where corporates alike, as well as students, as well as future generations are so excited about it, what do you think they need to be aware of when they are looking at a footprint? So do they need to consider just the electricity consumption of their servers where this algorithms are running? Do they need to consider the cloud aspect of it? Do they need to consider the way they've coded? What exactly goes inside calculating a footprint for a machine learning solution?
Yeah, I think there are different ways to approach it, but one way is to consider two things. So one would be, what stage of the AI system's life cycle do you want to make an assessment of? And then the other thing you could consider is what type of impact do you want to estimate? And the type of impact could be carbon footprint, CO2 equivalents, or it could be water consumption, soil contamination, all these other impacts. So those are the two main aspects, I think, in at least from my perspective. And if we look at the stages of the AI system's life cycle, it could range all the way from raw material extraction to end of life for the system. And in this process, the different stages are raw material extraction, then materials manufacturing, then equipment manufacturing, that is manufacturing the hardware, the GPUs and the CPUs and all these components that go into a server. And then the next stage in an AI system's lifecycle could be, or would be, at least according to this framework, would be the model training, which can be a very energy intensive procedure. And then the next stage would be what people sometimes call the deployment stage, or where the model is used for inference. And this is the stage in which you give users access to the product. So that's the stage that that ChatGPT is currently in. Although I think the process is not just linear, it's probably iterative, in the sense that you don't just train a model once and then never train it again. But if we look at this process from like a linear perspective, then you would have model training and then deployment. But probably the model is retrained every now and then. But maybe that's adding a bit of too much complexity. But you know, so the life cycle would then end with, you know, getting rid of this hardware once it's been used for so long that it no longer works, or that you might want to discard it for other reasons. And the stages that I typically look at are, of course, the model training, and this is the part of the AI lifecycle that has been receiving the most attention, I think, at least in academia. I think it all began, I can't remember the exact year, but there was a paper published by, I think the main author was Struble, maybe her name is Emma Struble, but it was called something like Policy Considerations for Large-Scale Natural Language Processing, something like that. They started this whole conversation, and then a number of papers were published afterwards, but they all tended to focus on this this stage in the life cycle that is model training. But I think it's also very interesting to look at model deployment, the stage in which users are using this product, because although the training of a model can have quite a big energy consumption, for instance, training GPT-3, which is the underlying language model for at least the early version of ChatGPT, consumed 1,200, or let's put it in kilowatt hours. So it was like 1.2 million kilowatt hours. And the average Dane consumes 1,600 kilowatt hours in an entire year. So training GPT-3 had quite a big electricity consumption, and it's estimated that the carbon footprint from training GPT-3 was 552 tons of CO2 equivalents. So that's quite a lot. But although that this is quite a lot, the impact from the deployment stage can be even bigger. And I think we have already reached the point when looking at ChatGPT where it's the carbon footprint and electricity consumption from the deployment stage has already by far exceeded the impact from the training stage. According to my own estimates, ChatGPT's monthly electricity consumption could be 3 to 4 times the amount of electricity it took to train the model. So it's very, what I'm trying to say, I guess, is it's very important also to consider the deployment stage. And then recently I picked up an interest in also the stage that comes before the training stage. Recall that the process was raw materials extraction, materials manufacturing, and then equipment manufacturing, which is manufacturing the GPUs and the CPUs and so on. And I've recently picked up an interest in this, in also considering the carbon footprint from manufacturing this equipment. This is sometimes referred to as the embodied emissions of a piece of hardware. Unfortunately, NVIDIA is a GPU or a hardware manufacturer. They produce a GPU that is called A100, which I think is the most widely used GPU for like heavy AI workloads. and they unfortunately they don't disclose the embodied emissions of their products. But Hewlett Packard Enterprise, they also produce similar equipment, and they have released information about at least one of their servers, and saying that this server has the embodied emissions from producing one of these servers is 2.5 tons of CO2 equivalents. And it's estimated that currently ChatGPT requires almost 29,000 GPUs to to run, and these GPUs are placed in servers that contain 8 GPUs each, probably, or at least that's an assumption. So that means that there's 29,000 divided by 8. That's the number of servers that you need. I can't do the maths in my head, but I think it's like what is it, 3,600 or so. But so let's say you need 3,600 of these servers that ChatGPT is running on, and let's assume that the carbon footprint of just one of these servers is at least 2,500 kilo CO2, or 2.5 tons. Then the embodied emissions from just using or just having this equipment, or just manufacturing the equipment, is also quite noticeable, and probably much larger than the carbon footprint from the training stage. So this is also just to say that it's very important also to consider the stage in which the GPUs and the CPUs are manufactured. And then when you want to look at the electricity consumption and the carbon footprint of a system like ChatGPT, you basically need to know how much electricity it consumes. Then you need to know the so-called power usage effectiveness of the data center in which the hardware is located. Then you need to know the carbon intensity of electricity in the region in which the data center is located. Those are basically the 3 numbers you need. You multiply each term, and this will then give you an estimate of the carbon footprint of some sort of AI system. But this also applies to all other types of digital products, whether it's AI based or regular software. Yeah.
Thanks for clarifying the life cycle, Kasper. So if I look at the life cycle that you mentioned, right from extracting the materials to prepare your hardware, to the way you've manufactured those equipments, where your hardware manufacturer, chip manufacturers like NVIDIA, Intel, Qualcomm, they could start playing a role, to the aspect of how the servers and clouds have been used to configure the setups there. Then comes the aspect of how you are utilizing it to write your machine language code, where you are training your algorithms. And then, of course, lastly, we as consumers using those algorithms to derive some value out of it.
Yeah,
so it's a fairly complex, long chain of different players who come into this, right from a raw material provider to a manufacturer, to a software engineer, a data scientist who may be writing those algorithms, to the consumer who is finally using it. So it's a fairly complex, if I may use the term, supply chain to create this one piece of AI. Now, when you have this kind of a setup available, and there are also a lot of people who want to know, where do we get started? Because as a software engineer or as a data scientist, they may not be able to influence the entire chain. They may be able to influence a part of it. Now, what advice would you tell to these people who probably play just one part somewhere, but are very keen to get started on this journey and want to make sure they don't make the matters worse? What advice would you give them to say, how do you start by calculating things?
Yeah. So if we imagine that this advice is for software developers and data scientists, they can directly influence the model training stage of the AI lifecycle and the model deployment stage of the lifecycle. I think first and foremost, you should start to measure the energy consumption of your software. That's the point of departure for this this journey that we want people to be on. Because if you don't know the energy consumption and the carbon footprint of your software, then you won't know either if the stuff that you are doing to reduce it actually works. So that's pretty simple. And it's actually also pretty simple to actually do the measurements. Most data scientists, they use the programming language called Python. And there's a great package for Python called Code Carbon, which it's open source and it's very easy to use. With just a few lines of code, you can have this package measure the energy consumption of your computational procedure, and then this package also detects the location of your hardware, and then it makes a lookup in a table of carbon intensity of electricity in the region that you're working in, and through this it can produce an estimate of the carbon footprint of your code. So what it does, just to sum up, is it makes an actual measurement of your electricity consumption, and then it uses some crude assumptions to make an estimate of your carbon footprint. And it's very easy to use, and I would encourage everyone to take a look. It's literally 3 lines of code or something like that. So very, very easy to use. And I think it's also very important for data scientists to, it's going to sound like a no-brainer, but I think it's quite important to keep in mind that you don't always need a very complex solution to a problem. It's like I can relate to people who want to start using some deep learning model for some type of problem, or who may be looking for a problem where they can apply deep learning, because deep learning is very exciting. At least that's my opinion. But it may not always be necessary to use deep learning, or maybe you should look at problems where you don't need to use deep learning. So that's also just like a mindset thing. You could, for instance, if you want to deal with some natural language processing problem, you might not need a big natural or a big language model to solve the problem. Maybe some regular expressions can get you where you need to be. So that's just something to keep in mind. There's another thing that I think is really interesting, which is to draw some inspiration from sustainable web development. Within sustainable web development, there's a concept called page weight limit, which essentially sets a limit on how many kilobytes a web page can take up. And so when you start developing a new service, and let's say a new web app, you can specify how many kilobytes the entire app is allowed to take up. And this has a direct effect. The weight of a website or a web page has a direct effect on its energy consumption. So you can say for this new app that you want to develop that you can have a maximum of whatever page weight. And then once you start developing, you need to constantly keep this in mind. How can I write this more efficiently, or can I use a different font that doesn't take up as much the space in my system? There are all these considerations that you need to really pay attention to in order to keep your page weight limit, which I think is a very interesting idea if we take this and apply it to AI and machine learning. So once you begin a new machine learning project, you could specify that you can only use, I don't know, let's say 100 kilowatt hours of electricity for training models. And this will force you to, be very critical of what experiments you begin, or what type of hyperparameter tuning procedure that you use, because everything you do in machine learning, in a machine learning project during development, has some sort of impact on the electricity consumption of your entire project. And I think it could be a good way to force yourself to think about this type of problem. Then this was actually, I wanted to add one thing. A good side effect of specifying a carbon budget for your project is that it will also be cheaper, most likely, because I don't know the exact relationship between energy consumption and costs. It could be, it's probably not linear, but anyway, I think it's safe to say that the less carbon you emit, the less electricity you use, and the less money you spend. So that's also something to keep in mind. You can make your whole project cheaper if you also reduce your carbon footprint, which could be a way to make the project managers and product owners happy. And something else you can do, which I think is also a very interesting idea, is to use model distillation. Model distillation is, simply put, it means that you train a smaller model to imitate the behavior of a larger model. This obviously will increase your electricity consumption during the life cycle stage that's called model training or model development, because you have a big model that you have maybe already trained, or maybe you just take an open source model, but then you train a new model to imitate the big model. That obviously adds some electricity consumption and carbon footprint to your process, but it could reduce the energy consumption in the deployment stage of the AI system's life cycle, because a smaller model will tend to also be, everything else held equal, to be faster during inference, and faster during inference will probably mean less energy consumption. Yeah, so there's a concrete example. There's a language model called BERT, and some people distilled BERT so that it became DistillBERT. And DistillBERT was 40% smaller, and I think 60% faster than BERT. So this is something to also keep in mind. Maybe you could, distill your models to increase the carbon footprint in your model development stage, but reduce it in your inference stage. But this obviously assumes that your product has enough uses or a long enough lifetime to break even on the investment that you put into the model training stage. But for something like ChatGPT, where there's a huge amount of users and we can probably expect a long lifetime, it will make sense. I think they probably have already done this, but it's not to say that they should have done something differently. It's just to say that if you have a widely used product, then this is definitely something you should consider.
If I try and summarize a couple of things that you mentioned, I think the first and foremost part is make sure you measure things. If you are not aware, you cannot know what changes you are doing, right? So things that you mentioned about code carbon, utilizing some of those kind of tools as part of your Python library would be a start. The second aspect, and I would like to see if I can draw some parallels from the reduce, recycle, reuse mantra that we typically have in sustainability, where reduce in a way that see whether you truly need machine language processing and heavy models to be used. You may not, as you rightly said, you may not want to complicate matters. There could be a simpler way of doing some things, right? So reduce the usage itself by truly asking the question, do you need it? Or is it something that you are doing just because it sounds cool and somebody else says that you should use AI there, right? So that's one angle that you said you need to bring in. The other aspect that you said, and recycle may not be the right word, but essentially model distillation to see if you can mock the behavior using smaller footprint models rather than testing it on a big model where the consumption of running those, deploying those will be much higher, right? So at least during the test phase, during the development phase where you are testing out your solutions as a scientist and as a software developer, you can look at model distillation. So essentially you are trying to make sure that wherever possible, you are trying to cut it down.
And then, with regards to the reuse thing, this is maybe it will also sound like a no-brainer, but you know, there's a lot of opportunity for reusing other people's work in you know, in software development and in data science. There's a lot of open source models for many different types of problems, particularly on Hugging Face. So there's, if you want to do something in computer vision or natural language processing, I think most of the time you don't need to train a model from scratch. You can, you know, take an open source model and then maybe you need to fine tune it. But no, in most cases, I don't think you need to train from scratch. Obviously, we have been talking a lot about students, and you know, in an academic setting, or if you're doing a project in your bachelor's degree or in your master's degree, you probably need to train from scratch, you know, just to get a sense of what it means and to, you know, impress the teacher. But yeah, in a real life setting, once you graduate and you enter the labor market, there's I think the occasions where you need to train a language model from scratch are quite rare.
So truly use the mantra of reduce, recycle, reuse in what we do. And it doesn't matter whether it's AI also, these principles can be easily applied, and it's not bad to refer to some open AI sources and models which are existing out there. You can always capitalize on what somebody else has developed. And in the process, make sure that your things not only are developed sooner because there's something ready, but also they are more greener because they have been already trained based on some previous data. So lot of interesting points, Kasper. I'm sure there are going to be a lot of takeaways for our listeners as well. And I would love to have this conversation going further around the AI as well as the other aspects. So what we will do is we would love to have you back on this Fireside Chat for a next deep dive on some of the aspects that you mentioned and address our community members. Thank you so much. Sorry.
Yeah, you're welcome. Yeah, thanks very much for having me on. And if you invite me again some other time, I will definitely accept the invite. So thanks a lot.
Thank you.
Yeah, it's been a pleasure.
Thank you so much, Kasper. Thanks for joining us today.
Yeah, you're welcome.